So today we'll discuss about super-pave. Okay. Super-pave, that means superior pave. Super-pave basically indicates a superior pave. So basically we'll be going through what are the different basic things which you have to follow while designing a super-pave. So if you derive the term super-pave, it indicates superior performing asphalt pavement. Okay, superior performing asphalt pavement. So that evolved from the strategic highway research program studies, and the basic concept involved in superpave are briefly discussed over there. So superpave is a superior pavement materials which is used in extensively in different areas like your airport designs or other expressway design like that. So, what are the different properties of the different binder materials or different component of the superplate? We will discuss in this unit. So, first one is binder selection. So, basically, binder selection is a very important portion for the superplate. So, binder means your asphalt or your bituminous material, that is the binder you required for the asphalt mix or your bituminous mix. Now, these binder selections have different characteristics that how you select the binder. So, in the binder selection, you know that temperature is an important parameter that affects binder behavior. Okay, so basically, you know about these things that bituminous materials is highly temperature susceptible, and because of the variation of the temperature, its properties changes. Now, superlative mix specification thus identifies the acceptability test should be carried out at the prevalent field temperature and not in the laboratory specified temperature. So this line is very important. This indicates that in normal cases, suppose for your penetration test or suppose some for your ductility test or your sorting point test, there are some temperature is mentioned. Okay, some temperature is maintained in the test, like 30 degrees Celsius or 35 degrees Celsius or 24 degrees Celsius, that is. So basically, the temperatures are lab regulated temperatures. The temperatures are lab regulated temperatures. Now, this lab regulated temperature is will not be similar as in the field condition. Okay, so therefore, in the supertube design, the first thing is whenever you are testing for any material, that testing should be done with corresponding to the field temperature, not the lab temperature. Because if you do the test in the lab temperature, in that case, it will not indicate what should be the actual condition in the field whenever you are using that material in the practical field. So this is first thing. So because of these things, your binder selection will be very much practicable in case of your super grip design. Now this is an important and unique consideration because bitumen from two different sources may show the same physical properties at a particular temperature, but but can show different properties at different temperature. Okay. Now, thus in superpave, only the acceptable test values and not the test temperature are recommended. Okay, so thus in the superpave, only the acceptable test values. So suppose you are doing this test in different temperature, in that case only the acceptable test values, whatever test values are acceptable, that are recorded, because you cannot temperature values, not the test temperature are recommended. Because why test temperatures are not recommended? Because in the actual field temperature may vary depending on the different environmental conditions. So therefore, if you record only the temperature, in that case, it will not show you some value. Suppose you are saying that your penetration value at 30 degrees Celsius, you are getting like 80 or 70, like that. But in the field, that temperature may be 40 degrees Celsius, maybe 45 degrees Celsius, maybe 20 degrees Celsius. So in that case, you have to consider about all these things. Now, how this temperature are maintained? Rather the testing temperature, you have to mention what is the maximum and minimum temperature with respect to the field. And based on that minimum and maximum temperature ranges, you have to find out whether your bituminous binder is adequate for the site condition or not. Now see, as per the Super-pave design, a binder is identified as PG T1 T2, where PG stands for performance grade. Here grade is performance grade, and T1 and T2 are the temperature limits. That is, one is higher temperature and another one is lower temperature. So within that particular range, the performance of the binder is checked. Now for the normal pavement, what happens? Whatever binder you have got, you tested that binder at a particular lab temperature. But for the super-pave design, you are testing that binder with respect to the field condition. Now in the field condition, the temperature will be varying. Therefore, you will uh, take some ranges of the temperature, and that ranges would be basically based on the field condition. It would be, one would be minimum temperature and another one would be maximum temperature, and within that minimum to maximum range you have to check the acceptability of the binder material over that place. Now there are different test procedure which is followed in the binder selection. So these tests are rolling thin film oven test, then pressurized aging vessel test, dynamic shear rheometer test, rotational viscometer, bending beam rheometer, and direct tension tester. So these are some of the tests which determines the viscosity of the binder material. Now, dynamic shear geometer is used to measure the viscosities of the bitumen at high and intermediate temperatures. And rotational viscometer is used for high temperature viscosity measurement, like those at the time of mixing or pumping. So there are different type of instruments, and they measure the viscosity, but they measure the viscosity at different temperature. Like for your dynamic shear rheometer. The dynamic shear rheometer is used to measure the viscosities of bitumen at high and intermediate temperature. That is, you are liquefying a bitumen content. After that, that viscosity could be measured by your dynamic shear rheometer. Then rotational viscometer is used for high temperature viscosity measurement, like those at the time of mixing or pumping. Now, if you are increasing the temperature of the bitumen, in that case, it will be more liquefied and its viscosity will be reduced. In that case, uh, that type of viscosity could be measured by rotational viscometer. And bending beam rheometer measures the stiffness of bitumen at low temperature. At low temperature, what is the stiffness of the bitumen, and the stiffness value is corresponding to the viscosity of the bituminous material. So this is all about the binder selection for the super-pave. So the remember one thing, for the binder selection, no additional material is used. That simple binder is used, but that binder selection should be based on the field condition, not the lab conditions. And here you will define some range of the temperature based on the field condition, and you have to check whether your binder is acceptable or the performance of the binder is acceptable or satisfactory within that particular ranges of the temperature. Now the criteria for the aggregate properties that also depends on existing traffic level, and existing traffic level means what are the different types of vehicles are moving over the surface, and the position of granular layer inside the pavement structure, and what are the different position of the granular layers in the pavement structures. Now, what are the different properties which affected the strength parameters of the aggregate or selection of the aggregate? So basically, these are coarse aggregate angularity. So we know what is angularity, and we have calculated some numericals based on the angularity numbers. Fine aggregate angularity. Similarly, for the fine aggregate, also you have to find out what is the angularity. Flakiness and elongation. How to know what is the flakiness and elongation? Basically, they are the shape test of the material to know whether a particle is flaky or elongated. The clay content of the aggregate. So basically, you have to find out what is the clay content in the aggregate, whether there is any clay content or not. Then abrasion test, you know about that abrasion test. Abrasion test is conducted to know the hardness of the aggregate particle. Then soundness test. Soundness test is conducted as a chemical test. It is conducted to find out whether weathering action will affect the aggregate or not, etc. Are the different types of tests or different types of properties based on which the properties or the particular aggregate batches are selected. Now, angularity ensures adequate shear strength due to aggregate interlocking, and limiting flakiness ensures that aggregate do not break during compaction and handling. So, if that aggregates are angular, in that case, proper shear strength would be developed in the aggregate because of the interlocking properties. And if you limit the flakiness and elongated aggregate, in that case, whenever load is applied over the aggregate, in that case, it will not break. The aggregate will not break. Now, breaking of the aggregate is not good because when the aggregates are broke down with the application of the load, in that case, it will make into dust particle, which reduce the load carrying capacity of that particular road section. Now, this is one committee that formed 14-member expert task group to evolve an appropriate aggregate gradation. So, what should be the appropriate aggregate gradation? They have tested this for the Super-pave. Now, this group, after several experiments and discussion, decided to use a power gradation of 0.45 as the reference gradation with certain restriction zones and control points. So, what is this power gradation? I will discuss this later on. Now, if you remember your aggregate gradation, that is batch mixing formula, in that case, there was one formula is there, that P equal to T to the power 4 something. Basically, that is your power equation. So, in this power equation, a power gradation, okay, power gradation of 0.45 as the reference gradation with certain restriction zones and control points are selected. Now, these restriction and control points are incorporated in order to ensure certain proportion of fines, and they are following reason. So these restriction zones, some restriction zones are there. Restriction zones means like your aggregate angularity number should be like that. Your aggregate flakiness and elongation should not be more than that. Like these are the different your restriction zones. Now these restriction zones have some properties like that. Proper interlocking of the aggregate. So basically, this restriction zones enables the proper interlocking of the aggregate to avoid the falling shear strength of the mix due to excess fines. Therefore, you have to regulate the number of fines over there to maintain the requisite VM for in mineral aggregates that you have or you have to maintain. Okay, what is the requirement of the VMA that you have to maintain in the aggregate, because that VMA is very much necessary in your bituminous mixes, because if there is VMA then only bitumen can penetrate into the VMA and occupy the place and create a better bonding between the aggregate particles and bituminous particles. Now, these control points and restriction rules serve more as a guidelines for selecting a gradation rather than a compulsion to be followed. So basically, that is the guidelines you can follow. So basically, these are the different super-pave gradation. So SIP size raised to 0.045 into power. Power means whatever SIP size, normal SIP size you are using, you have to raise that super pave with a power of 0.045. That is, if you are using a SIP size of 6 mm, then in that case it would be 6 mm to the power 0.045, like that. So basically, these are the different percentage passing, and these are the SIP size, modified ship sizes. After that, you have to find out what are the gradation, and if you are getting like that, these are your basically your restricted zone. So this is the zone where you are getting your maximum density, and these are basically your control points. Okay, so basically your line should be in between all these control points, so that this line is almost in a proximity with all the control point. So the nominal maximum size is defined as one ship size larger than the first ship to retain more than 10%. So the nominal maximum size of any ship assembly is defined as the one ship size larger than the first ship. Suppose you are using a first ship of 6 mm, then you are using a ship of 10 mm, then 12.5 mm, like 16 mm, like that. In that case, your first ship size is, if suppose your first ship size is, if you arrange that ship to severe particles, in that case, your first ship size would be 12.5, or sorry, 16, then it would be 12.5. So your nominal sizes would be basically the second ship size, that is 12.5 mm, and the condition is if it retains more than 10% of the material. In that case, that would be defined as a nominal ship size. The maximum size is one ship size larger than the nominal maximum size. So maximum ship size would be if there are different ship sizes, you have to find out what are the nominal sizes. So nominal sizes would be basically the ship sizes where that percentage retained would be more than 10%. So from these different nominal sizes, you have to find out which one is the maximum one, and your maximum size would be the one size larger than the maximum nominal size. Now, next thing is super-pave volumetrics. What are the different volumetric characteristics of the super-pave? The super-pave emphasize the fact that some amount of bitumen is absorbed by the aggregate and therefore remains ineffective. So basically, that is a general concept which we have already studied. That for the pavement and aggregate mixers, some of the bitumen could be penetrated further into the inaccessible gaps or pores of the aggregate particles which remain unused for your bonding. So thus the amount of bitumen which is effectively available in the mix should be considered for deciding the optimum bitumen content. So for the compaction, Super-pave developed a new compactor named Super-pave gyratory compactor, which was developed keeping in mind the specific objective as follows. So for the compaction, you need after mixing the particular materials like your bitumens and aggregates and all these other fines, all this material, you need a proper compaction so that sufficient DMA and BFA quantity could also be maintained, and additionally your mix proportions or mix material would have sufficient strength to carry all the vehicle loads. So therefore, to enable the compaction for the super-pave design, one compactor specially for the super-pave design has been developed, and some of the features or some of the objective of this compactor is as follows. The compaction should be such that it simulates the compaction in the field, loading, and climate conditions. So basically, you are laying the super weight with the actual field, and where it will subject it to different combinations of load based on the traffic conditions and different type of weathering actions. So therefore, this compaction, whenever you are doing the compaction should be adhered to the actual field condition. Okay, you have to prepare or you have to create that environment in the lab so that actual field condition could be achieved. Then second point is the compactor should be able to accommodate large aggregate. If there is large aggregate, that also should be accommodated in the compactor, and the device should be portable enough so that it can be used in the field for quality control process. So these are the three main objectives of the compactor, and based on these three objective, that one new compactor is developed, that and it is named as Super-pave gyratory compactor, and that particular compactor is used for the Super-pave design or compaction in the Super-pave design. Now, the principles of gyratory compactor were used to modify the Texas gyratory compactor, and finally the LGC evolved. So basically, there are different types of gyrator was there, like French gyrator compactor and Texas gyrator compactor. So if you want to know about basic of this gyrator compactor, in that case, just write down the terms and check it in the net. And using this two gyrator compactor, and by enhancing their properties, that finally HGC or your super-pave gyratory compactor has been developed. Now in this case, the mold can accommodate maximum aggregate size up to 50 mm. Okay, that is the mold which can accommodate maximum aggregate size. Now, if the aggregate sizes are maximum, in that case, your mold size should also be higher. In that case, your mold size is 150 mm. And in HGC, the test mold is placed on a tilted base that is 1.25 degree rotated at a certain frequency 30 gyration per minute while being subjected to compaction pressure of 600 kPa or more depending on the field condition. Now why it is tilted? Because in the actual field your rope surface is not flat. Okay, if it is not flat, because of the camber section it will be tilted. So basically tilting condition is basically provided to uh, to stimulate the actual field condition. Okay, and your it would be rotated to uniformly distribute the load over the pavement surface, and a compaction rate would be 600 kPa. Now this compaction rate is also not fixed. That compaction rate will be depending on the field condition. So in the super-pave design, the main concept is whenever you are designing for the super-pave, all the testing materials should be tested based on the actual field condition rather than the laboratory maintained temperatures. Then height can be measured at any point of the test, which in turn gives the measure of the compaction level achieved. It may be noted that the gyratory compactor uses shear compaction input, whereas the Marshall compactor use impact energy for compaction. So basically, the two important thing is for the Marshall test also, you have to compact the specimen after preparing the mold. In that case, in the Marshall case, that compaction would be like a impact compaction, a sudden application of the load compaction. And in yeah, basically in the Marshall test, whatever mold is there, after preparing the mold, you will uh, drop some hammer type things over the mold to compact it. So basically that is a impact energy compaction. But in case of your super-pave gyratory compactor, here the compaction is shear compaction. So basically you are pushing all these things with a constant or varying load condition. Now the mixed performance is tested by two tests. One is super-pave shear test and another one is super-pave indirect tensile test. So in the shear test, it is used to evaluate the permanent deformation. Permanent deformation means rutting and fatigue cracking susceptibility in the asphalt mixes. So it provides vertical and horizontal loads to a cylindrical specimen at different confining conditions and temperature. So basically one cylindrical mold would be there and you will apply your horizontal loads as well as vertical loads. And that different loading condition would be different and it would be in different confining conditions and different temperatures. Now the confinements and the test temperature are fixed so as to simulate the field condition. So basically based on the field condition you have to provide the different confining or confinements at the test temperature. Suppose in a highly rainy area you are using the super-pave. Now you have to test the super-pave for its performance. Now suppose the average temperature of that area is 25 degrees Celsius. So your test temperature should be maintained at 25 degrees Celsius. Now as this is a rainy area, highly rainfall area, in that case it is quite acceptable that the super-pave or the pavement may be submerged in the water in considerable period of time. So whenever you are testing the material, there would be another confinement that the material, whatever you are using, that material should be well performed under the water also or in the submerged condition also. So basically, these are the different confinements you can provide in the testing system based on the actual field conditions. Now another test is there that is called Super-pave Indirect Tensile Tester. It measures the creep compliance and tensile creep of hot mix asphalt. You know what is creep compliance? That is in the creep condition. The stress divided by strain is the creep compliance, and tensile creep of hot mix asphalt. It is also used to evaluate the thermal cracking susceptibility of the asphalt mix. Thermal cracking susceptibility means whether because of the temperature fall, is there any susceptibility of the cracking of that material. So how this test is conducted? Load is applied to a cylindrical asphalt specimen through its diametrical axis, and the resulting deformations are measured for the static tip load and repetitive dynamic loading. So, so here load would be applied like this. So basically you are squeezing that cylindrical specimen. Okay, I have taken the attendance. You can leave.